yourself, you are more than welcome to participate in this class. So the lesson should be recording. What I need to do now, it is to share my screen. Then I will need some of you guys to confirm if you are able to see my screen. Then we will officially start with our lesson for today. So let's see. Guys, is there someone who's able to confirm if you are able to see my screen there? I'll just try to write something and you'll let me know. Can you guys see my screen?
Yes.
Yes, sir.
And also, can you clearly hear me when I speak?
Yes, we can hear you.
Yes, sir.
Okay, 100%. Guys, a very warm welcome to my lesson for today, where we are going to be looking at physical sciences. It's going to be our first trial lesson, and then from here, we will continue until you guys open schools. So obviously, as I've indicated, Newton's laws of motion is what we are going to be looking at in today's lesson. I'll just write that down and say Newton's laws of motion. It's what we are going to be looking at in today's lesson. Remember, guys, just in case if it happens that it feels like you are lost, do not worry that much. Just in case if it feels like you do not understand, do not worry that much. And most importantly, in case if there's something which is not clear, feel free to drop a message in the comment section to say, I have a question, or you can click on a button where you raise your hand. At some point, I will then give you guys an opportunity to ask some questions. And most importantly, whatever question that you have, there's no such a thing as a silly or a stupid question, honorable members. We learn through those tricky questions. We learn through confusions. So in case if you are confused, share the confusion with us so that it helps me to understand what you know, what you do not know, and to what extent you know what you know, understand what you understand. In that way, it is going to make it easier for me not to neglect information that could be useful to you. But otherwise, we'll just straight away get into it and then we'll figure out everything as we go. So now let's see. Guys, most importantly, I want us to talk about the forces. And we will spend much of our time looking into different types of forces acting on different objects or objects in different stages. So firstly, let's talk about what we call the non-contact forces. So the moment I say non-contact forces, automatically it means there must be contact forces. So these are the two forces that we are just going to compare for now, just so that you've got an idea of what we are referring to in terms of the contact and the non-contact forces. Remember, guys, a force exerted between objects over a distance without a physical contact, that is what we refer to as a non-contact force. Guys, I am going to share with you the notes when the time comes, but for now, we're just starting sketching. So do not worry that much in case if I define something and you feel like you had that definition. I will still share with you this information when the time is right. So if I'm not sharing with you at this point in time, it's possibly because it is not necessarily where I need your attention to be. So it's more like at this stage, I'm not that much interested in you fully knowing or claiming what is the definition of a non-contact force. But I just want us, honorable members, to discuss the types of forces, understand or have an understanding of how the forces can interact with objects, and then at a later stage, you will then see the need to know the definition of a non-contact force and a contact force. Let's just give examples, honorable members. You know, Mus, if you take, let's say, I'll use a different color there just so that it is clear that it's an example that if you take a magnet, we know that a magnet has got the North Pole and the South Pole. Trust me, honorable members, if you take another magnet, it doesn't matter whether it is the South Pole on this side or the North Pole on the other side. Trust me, honorable members, if you put these things close to each other, there is going to be some force happening there. Without this bar of a magnet being in contact or touching with that bar of a magnet. What is the definition of a non-contact force? It is a force exerted between two objects. It could be more, but for now, let's say between two objects over a distance. Over a distance without physical contact. This is the first example. Let me now try to indicate another example. This is the Earth, honorable members. Let's say this is the South African map. Myself, I'm in Pretoria. This should be, let's say, Limpopo, whatever. And then let's say this is Gauteng, and this is where I am. Maybe let's say this is those North countries, whatever the country may be. Trust me, honorable members, if for some reason someone here throws something upwards, this thing, honorable members, it will definitely go up and then it will make a U-turn going downwards. The question is, why does it not just go up non-stop? It is because this, which could be a stone, it is attracted towards the center of the earth. That's why it comes back to the earth. Even if you can take your pencil or your rubber, throw it up. You throw it up, it is going to come back because it is being attracted towards the center of the earth. So that means the rubber, it's object number one, the earth being object number two. Without them being in contact while it is in the air, in between, there is a force. What type of a force? A force of attraction. This is the second example that I'm giving. Maybe let me give the last example, and then from there we will summarize all that is to do with the non-contact force, and then later we will move on to the contact forces. Okay, you guys are from grade 10, and I'm pretty much sure that you do know that we've got those electrons. Those electrons where you might be having a charge being a negative charge. Again, you might be having, let's say, a positive charge, or it could be positive and a positive, otherwise a negative and a negative. We know very well that when you have these two charges close together, with opposite charges, what do? They attract each other. Something of that nature, honorable members. So with you just putting a 1 and 2 close to each other, there is a force in between, but these two objects or these two charges are not in contact. So that is why we end up having what we call a non-contact force, which is a force exerted between two objects over a distance without physical contact. This is the distance in between, but physically they are not in contact. So as a scientist, honorable members, you need to therefore summarize this type of forces. You need to give them names. So let us say the first type of a force, let's call it magnetic force, because we were talking about the two magnets. So that means a force that would fall under non-contact force. We can call that a magnetic force. So a question in an exam may come in a form of a multiple choice where they give you a list of forces and you need to tell which one is a contact or a non-contact force. Just remember that, honorable members, just in case you're wondering, how will a question come in an exam where I need to talk about the non and the contact forces? Okay, the second force, what example did we gave that example? Maybe because we know that it is actually the force of gravity that is pulling this stone towards the center of the. Why not give this type of a non-contact force a gravitational force? Gravitational force. So, honorable members, when you go to the clinic or hospital and they say we need to measure your weight, in simple terms or scientifically or in physical sciences, the weight and gravitational force, it is one and the same thing. Weight and force, one and the same thing. Just note that. Okay, the last example, the one that has to do with those electrons and wara. Let's refer to that type of force as electrostatic force. Electrostatic force. Okay, so how can we represent an electrostatic force in a short format? We usually represent electrostatic force as Fe. The E, which stands for electrostatic, and the big F for force. Then when it comes to this one, we can say Fg. The G for gravitational, and then big F for force. And then when it comes to the weight, what is that much we just use U. Magnetic force, it doesn't need a version of it because we won't need a formula where we calculate magnetic force. So that's why they've got those shorthand notations. Okay, before I move on to the contact forces, can I just ask if guys are non-contact forces? I think this will be a good opportunity. If you just respond with a yes or no, non-contact forces. Just unmute and then respond. Response. I hope you guys were able to hear me because I'm not getting a response from your side. Guys, are we okay up to this point?
Yes, sir. No.
Make the I made Mbali, I made you to break, or in case if whatever the case may be, you will just unmute yourself and then make me aware if there's an issue. But in case if I ask you a question, you don't unmute, wait until I unmute everyone. Okay, so now let's see. Did you get that, Mbali?
Yes, sir.
That. Okay, let me say no. I did notice, I think it was Chloe who said no. Ask her to unmute. Chloe, can you unmute yourself, honorable member? It's also, can you please more about magnetic and that? Chloe, do you have a question, honorable member?
Yes, I do.
Yes, go for it.
So I said, can you just please explain more about the magnetic force and also the electrostatic force?
Okay. Do not mute yourself. Let's have a discussion. Maybe the other guys will also have a better understanding. Do you know a magnet, Chloe?
Yes, sir. It's Chloe. Yes, I do.
Oh, Chloe. Okay, but are you aware that if you take a magnet and another magnet and put them closer together, are you aware or have you experienced that force that happens in between when you put them together?
The thing is, honestly, we didn't really do that top. Like, we didn't really go in depth with it in school, like in grade 10. So,
Eh,
like, we did it, but then not like that much.
Yes, no, worry that much about these examples. We will still go deep when we do calculations. But for now, I just want you to be aware that a magnetic force falls under non-contact force. And the reason to that is because when we take magnet 1 and magnet 2 and you put them closer together, can you confirm that you do or that of repulsion? Do you agree with me on that one?
Yes, sir. Oh, can I make sense?
Yes. Yes, that's all that you need to know for now. To say when you take object 1 and object 2, you put them together and they don't touch, you will still experience a force. So we are categorizing that force to say that force, it falls under non-contact force. Why? Because these two objects are not in contact with each other.
Okay. Makes sense, sir.
But there is a force in between. Makes sense.
Yes, sir.
Similarly with the charges. We know that we have a negative charge and a positive charge, isn't it? So a negative charge and a positive charge, they work almost like a magnets, if I have to simplify it to you, such that if it's negative and negative, they are going, but they are not in contact, but we know they are going to repel each other. And what is it? Not in that direction, actually, to be correct. It should be in that direction. Positive and positive, they are not going to attract each other. They are going to still repel. Yes. Unless if it's positive and negative, we know that they are then going to attract each other. Can you see? So we're simply saying it's object 1, object 2 that we can experience. Does it make sense now to everyone?
Yes, sir.
Guys, does it make sense to everyone?
Yes, sir.
Yes, sir.
Okay. Then it's fine. So what I want to do now, it is to discuss everything that is to do with contact forces. Okay. The contact forces, honorable members, they are straightforward. They won't need complicated examples. Okay, the contact forces, maybe number 1, we can talk about an applied force. So an applied force, let's say this is that being the wheelbarrow there. You carrying this, in that way you are applying a force. You know, most a wheelbarrow, you can push or you can pull it most. A wheelbarrow, you can push or you can pull. Even if it is a brick, honorable members, And again, you can still push it at an angle. Even with the pull, you can pull it at an angle. So can you see? Your hands are in contact with the object. So that type of a pull or a push force, we refer to that as an applied force. And then we shorten it to be force A, meaning applied force. You just need to know that a force which is being applied, it can be in a form of a push or a pull. These are just status, honorable members. We will look into how we represent the forces exerted on objects and how many types of forces do we normally focus on. And then on upcoming lessons, we are going to be starting with the calculation. But before you can learn how to calculate, you need to first be able to identify and interpret possible forces which may be acting on every object. When we say physical sciences, honorable members, it is physical in a sense that it has to be something that you can see, interpret, and make a conclusion. Just like I've explained now to say, you apply a force by pushing or pulling on any object. If you've got a calculator next to you, you can push it. Sometimes you can need a rope to pull an object, but with a wheelbarrow is a good example because you know as you move forward, you are pushing it, and then you can just pull it by going the opposite way. The next type of a force, honorable members, let's maybe talk about frictional force. Frictional force. And then the short version of it, we can say capital letter F for force, small letter f for friction. Frictional force, honorable members, we don't need to stress that much about this one. You know, when you have, let's say, a road which could be gravel, and then you have these are the wheels of your dream car. As this object or the car is moving in that direction, there is a friction between the wheels and the gravel road, between the wheels and the gravel road. Just like this is your table, you have your calculator there. If you rub or push this calculator forward and backwards, there is going to be that friction between the calculator and the surface of the table. And it is definitely going to make a sound if you push and pull by a force. So that is the friction that we are talking about. So that means the friction will therefore exist if there are two objects which are in contact, and the other one obviously being a rough surface. So that would be an example of a frictional force. Okay, the third type of a force being a contact force. Let's maybe talk about something called normal force. Yes, normal force. And then we can shorten this to say Fn or just capital letter N. What is a normal force, or when does a normal force occur? Guys, a normal force will occur if the other object is on a surface. You see, this is our gravel. That means this gravel is exerting a force in the upward direction on this object. And also this object is exerting that downward force on this object. And those two forces, they balance each other out. That is why this object is not falling towards the top or upwards, and it's also not falling downwards inside that surface. Another example, honorable members, this is your table. And this is your calculator sitting on that table. Why isn't this calculator of yours falling through that table? It is not falling, but it is stationary on that table. Why? Because this table, it is exerting an upward force, and we also have another force by gravity. And these two forces, they balance each other out. That is why this object is not moving in that direction or that direction. It just remains stationary there. So that means a normal force will be exerted by the surface. So if you want to know if a normal force exists, just ask yourself this question. Is there a surface? Yes. Is the object on the surface? Yes. Okay, then the normal force exists. Okay, under which instances do we not have a normal force? Let's say this is the Earth, nay, and this is an aeroplane. This is an aeroplane, nay. This aeroplane is somewhere in the air, honorable members. It's somewhere in the air, in the atmosphere. It is not on the Earth, meaning this aeroplane is not in contact with the Earth. It's not in contact with the table. Therefore, there is no normal force, because it's not like this Earth is exerting a force on that object, because to begin with, they are not in contact. So this is an example that I can use so that you understand under which instances a normal force would exist. But the moment this aeroplane lands on Earth and it stays there, the reason why it doesn't continue to fall inside the Earth, it's because it is being balanced by the normal force, or the force normal. We already know that there is that force of gravity which is pushing it downwards. But the reason it just remains there and does not continue to go downwards is because it is being balanced by the normal force exerted by the Earth. So that means there must be two objects. The other object must be on the other one, and then the surface will exert a normal force. Maybe let me introduce the last one, and then I will give you guys an opportunity to ask some questions if there's any. Otherwise, if not, then we continue. The last force that I would like for us to talk about is what we call the tension. The tension. The short version of it is just capital letter T, or if you like, you can just say force tension there. Okay, the tension force, it exists if two objects are connected by a string. An example would be, this is you with your German car, and this is me, honorable members. I'm stuck somewhere, and I called you to come and tow my car. So you tow my car. This towing bar, it is where we find the tension. This rope that connects these two objects, this is where the tension exists. So if you know that game with many of your friends on this side, and then we've got other honorable members on this side, and then we are playing that game where there is a rope and we want to see who's going to then cross this line, as this one's pull in that direction and this one's pull in that direction. So the tension exists. Where does the tension exist? In the rope. In a sense that this rope is experiencing a pull in that direction and again another pull in that direction. That's where the tension is. That's pretty much it, honorable members, with regards to the non-contact and the contact forces. For now, you don't have to cram those examples that I've given. It was just to make you understand what is meant by the non-contact forces and the contact forces and their examples. Just in case if it happens that your teacher says, we've got two types of forces, the contact and the non-contact, and they just give you a list of which you must know by heart. At least you've got an idea of the type of each and every force. So now, my question, guys, are we okay up to this point, or is there someone who's got a question? Remember, guys, this is a lesson for grade 11s. Everyone must be going to grade 11 next year. Otherwise, if you're in grade 12 and you just need a revision, just like the other parent said, you are also welcome. So, guys, are we all on the same page up to this point? Yebo noma cha?
Yebo.
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 Okay. Okay. But wait, Kawe, is it you, the honorable member from, was it this year or last year? I think it's you. Chloe, yeah, I remember I used to say it for her. Hmm? Is it you? I think so. Okay. Figure that out at a later stage. But for now, let's continue, honorable members or members who are honorable. Okay. What I'm going to first start with. Okay, we are going to start with the normal force. Let's start to talk more with regards to a normal force. Remember, guys, it is not our last time doing these things. We are still going to revisit all that we are doing now at a later stage, especially when the time is right. But for now, it's just to introduce you guys to some of these things. Something that you need to be aware of, honorable members, is that the normal force is equals to the force of gravity. This is a formula. How are they equal? Okay, you have a surface, which could be your table, and then you have your calculator there. Something is happening there, honorable members. Two forces are acting on that object. So now the forces that I'm going to be talking about going forward, it is all these forces and also that one there, force of gravity. These are the forces that we are going to be talking about going forward. This one of magnetic and that one of electric, those two, we are not going to be talking about those. It was just to differentiate between the two. So, meaning we will try to have different types of diagrams just to learn the interactions of the force applied, force normal, force of gravity, force of friction, and the tension. Yes, 1, 2, 3, 4, 5 forces. We are just now starting with the normal force. So now I've just explained to you that the normal force is equals to the force of gravity. How so? Okay, when you look at this object, there are two forces acting on this object. The first one, it is this one called force of gravity. So whether the object is in contact with the other object or not, force of gravity will always be there. Just be aware of that. Force of gravity will always be there. The moment it disappears, or God decides to switch it off, everything is going to float, honorable members. It's going to be like those guys in a record. No, not a record, but a rocket somewhere in Mars or in the moon. They are just floating. Why? Because there is no force of gravity. There's no pulling force. So what I'm saying is, if for some reason God decides to switch off, now as we speak, switch off that force of gravity, everything is going to float, honorable members. You will see calculators going that way, you'll be going that way, and everyone will be all over the air. But the reason why we are not all over the air is because we are being exerted on earth by the force of gravity. It's always exerting towards the earth. It's like you are having the earth, and there is this invisible air, a very strong invisible air, which is just pulling everything towards the center of the earth. That's why we are not floating in that direction. It's because of this, of which I'm saying, if God decides to switch it off, then we'll just be all over. We'll just be all over. Okay, the other force, it is this one, being the normal force. Why are we saying these two forces are equal? It's because they are balancing each other. If they were not equal, that means this object was supposed to move either up or down. But for the fact that this object is not moving down or up, it means this force is balancing with that one. Think of it as you, and then another honorable member there, and then there is this stick. And you guys are trying to pull in that direction, and then this one pull in that direction. But no one is moving. It is possibly because maybe this one is pulling at 50 Newton. Even if this one is pulling at 50 Newton in the opposite direction, it means no one is going to move. So that means you will just remain in your positions. Why? Because the force in that direction is balancing the force in that. So that means the force that is pulling towards the left is equals to the force that is pulling towards the right. That's why in this case, it is the up and down forces. That's why we're saying the force that is pulling upward is equals to the force that is pulling downwards. I'm not sure if this makes sense, honorable members. Before I continue, let me just check if we are all on the same pages on that one before we look at other types of forces acting in different ways on other objects. Guys, are we together up to this point?
Yes, we
Yes.
are.
No. No.
Amila Nas. Okay, Amila Nas, what's the question, honorable member?
The example that we have done.
Mm-hmm. Yes, the honorable member. Just describe that part that you do not understand on that example. Okay. No response. I'm just going to mute, or maybe I'll say no. Okay. So guys, just so that we are able to move forward, in case if you do not understand something, at least try to describe what's confusing so that I'm also able to explain. Because if I have to re-explain this, I will still have to say the same thing, honorable member. The short part of it is that if you have a big brick there, you are standing this side and you are pushing this brick in that direction. Another one here is pushing in that direction. If you are pushing with a force of, let's say 30 Newton to the right, and this one is pushing with, again, 30 Newton, but to the left, this thing is not going to move because the force that is pushing towards the right is equals to the force that is pushing towards the left. This object will just remain there. But here, when it comes to the normal and the FG, the normal is always exiting upward, and then the FG is always exiting downward. The question now is, this object, is it moving? No, it's not moving. That is what we say the force pushing up is equals to the force pulling down. But do not think that much about this one. I forgot the name of the honorable member. But you need to be aware of is that we've just indicated how a normal force acts on an object. And again, simultaneously, we've explained how a gravitational force can act on an object. Let's now go ahead and look at how an applied force can act on an object. So let's see. I'll just have an object there. And then again, I will say this object is on a surface. Remember, we said always, all the objects will always have force by gravity. And if this object is on a surface, the surface will always push upwards, being the normal force. It will always push in the upwards if that surface is horizontal. So that means the angle formed there, it is 90 degrees. So those are the two forces that I've explained so far. Now let's add another force. What type of a force? Applied force. What do you guys remember about applied force? We said it could be a push force or a pull force. So how are you going to know which one is a push, which one is a pull? It is the arrow. In physical sciences, the arrow speaks louder than words. You know when they say actions speak louder than words, that means this line is the action, but the arrow, actions speak louder than words. So that means this line is words, and then the arrow is the action. Yeah, something of that nature, honorable. So in short, I'm trying to say, be very careful of the arrows in physical sciences. They speak louder than words. For example, if I do this and I say, this is an applied, it's not an applied force if it doesn't have an arrow. If you just put a line there, then it's just a line. You must put an arrow there, then I will tell what type of a force it is. If you do this, then I know it is an applied force, which is pushing. You can see the arrow is pushing that. But if you have this one, and then you have the arrow there, it is an applied force, but this one is pulling. So that is the difference between the pushing and the pulling applied force. And you can see that this pulling and pushing applied force, they are acting at a certain angle to that object. How will the applied force look like if it is not acting at an angle? So that means, again, you can have an applied force. Obviously, you already have this as force of gravity, and then you have that one at 90 degrees, which is the normal force. You can have a force horizontally like that being the applied force, or you can have it like that or in that direction as an applied force, or it could be a pulling applied force in that direction or in that direction. So this is how an applied force can be represented on an object. Again, I'm just going to say we have covered an applied force, and I'm about to explain these other forces. So let me check. Guys, are we okay with regards to the applied force? Do you have an understanding of how an applied force can act on an object?
Yes.
Yes, sir.
Do we
Yes,
all
sir.
understand, honorable members?
Yes, sir.
Okay, 100%. So very quickly, let's talk about this other two remaining forces. Obviously, let's go with the frictional force. So when it comes to the frictional force, honorable members, every time I will start with the forces that we already know. On this object, you can have, these ones are compulsory, you will always have. You see FG, you will always have. Normal force depends if the object is on the surface. Yes, it is on the surface. That means the normal force exists. The applied force, it depends if they say it is there or it is not there. But for now, let's say it is there, and then it is towards the left. So if you want to know in which direction is the frictional force, you just need to know in which direction is the object moving. I'm asking it to you as a question. You can just respond wherever you are. No need to unmute yourself. This object A, as it is being pushed by the applied force, will it move towards the left or towards the right? Obvious, it's going to move towards the left because of the arrow is pushing it towards the left. That means the frictional force will be in the opposite direction. So it all depends on where is the object going. Is it going towards the left? If it's going towards the left, friction is always in the opposite direction. If the object is moving towards the right, frictional force is opposing. That's it with regards to a frictional force. No stories there. Does it make sense, honorable members? With regards to the frictional force, it's just a matter of where is the object going? Is it going up? Okay, if it's going up, friction going down. That's it. Left, right. Does it make sense, honorable members, regarding the frictional force?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Then it's fine. So now, let us talk about the tension. So the tension will exist if you have two objects being connected. There must be two objects which have been connected by something. There, let's say connected by a rope. And then, of course, these two objects are on a surface. Okay, let's talk about those other forces that I've explained. I said this one will always exist. Always. As long as there is an object, it will always exist. What about the second one being normal force? It depends if the object is on the surface. Are these two objects on the surface? Yes. That means there is an upward force from the surface going up. That angle must be 90 degrees, being normal force. And this one also, in the upwards, it has a normal force. And then when it comes to the applied force, it depends on whether it is there or not. If it's not there, it's not there. How are you going to know if it is there? It means it must be shown to say there is that applied force. That's how you will know if it is there. It will either be shown by an arrow on the diagram, or if you are given statement, it will be explained to you that there is an applied force on the object. If there is an applied force, then we ask ourselves a question. This surface, is it rough or smooth? In physics, if it is rough, frictional force will exist. If this surface is rough, the frictional force will exist in that opposite direction of the applied force, or in the opposite direction where the object is moving. What if this other surface, or this part of the surface, it is not rough, but it is smooth. If it is smooth, then it means frictional force will not be there. But if it is rough also, then frictional force will exist. How are you going to know if the surface is rough? You will be told. You will be told. How can you be told? When they say the surface is rough, or they will say it is smooth. So now, when it comes to the tension, honorable members, when it comes to the tension, you just know that in this rope, there are forces in opposite direction. There is this one in that direction, and then another one in that direction. That's how we say this rope is experiencing the tension. It's like this object, let's refer to this as object B. It's like object B, it is pulling that object A. At the same time, it's like object A is pulling this one. Even though everything as a unit, it moves towards the right. But what this rope is experiencing is like it wants to tear where this one, it experiences a forward direction as a result of that, and then also that. Think of it this way, honorable members. Imagine you have two people pulling you into opposite directions. There's this one pulling you, there's this one pulling you. You will feel like half of your body once is being pulled in that direction, and then half of it is being pulled in that direction. This is where these arrows are coming from. Or if I have to use this example as to why are we having two arrows in two opposite directions, is because as a result of this object, it's like it's pulling. Also, as a result of this, it's like it's pulling. Therefore, this rope connecting these two things is experiencing a tension. And in terms of the arrows, this is how we represent that tension. Guys, did that make sense, honorable members? What I've just explained there. Did that make sense?
Yes.
Guys?
Yes, sir.
Are you sure? Ningasabi, Nsika. Guys, just unmute all of you and respond just to test your mic.
Yes, it
Let's
makes
see, we've got
sense.
Mbali Pukamuso, Mbalentle, Ntando, William, Senzo, Amila. We've got Bukamuso, Chloe, Ethan More. We've got Hamza, Mhlongo, Nogutula, Nontlantlantziga Titelo. Guys, are we okay up to this point? Because this is actually the end of our lesson for today, where we just looked at
Yes, sir.
these 5 main
Yes,
types
sir.
of forces, where on our next lesson we'll be looking at some calculations and the formulas. But up to this point, we are okay, most honorable members. Any last questions from your side, or all is good?
Yes, sir. We understand.
Understand.
Yes.
All is good. Okay, then it's fine, honorable members. I am very much impressed with your attendance, members of parliament. Just make sure that even for maths lesson, I think you can just verify on your timetable. I think it's tomorrow. Just make sure that in case if you're doing mathematics, you also attend, because we're going to be doing some new stuff that you guys are going to come across in grade 11. But trust me, this information is going to be very useful, because you will also use it in grade 12 next year. So guys, all that you had to learn in today's lesson, it's nothing much other than knowing that there's what we call applied force, frictional force, normal force, tension, and gravitational force. And we can categorize this type of forces into the non-contact and the contact forces. And also, what we have just learned is how we represent these forces on an object. On our next lesson, we will look at how to formulate or how to derive formulas, and then the other lesson, how to calculate or how questions are being asked. So guys, I will just end it here. Let me sign out because I'm preparing for the grade 12 lesson and say, guys, I do thank you very much for joining. Trust me when I say my name starts with a letter D, and guess what? I am out.